Now we'll demonstrate an ARP cache poisoning attack. We'll use a widely available program called Kane-Enable, which has many additional functions, but can be used for ARP poisoning. Before we start using the program, let's examine the victim's ARP cache. In order to see the contents of the ARP cache, you just have to type in ARP with the parameter A into the command line. As you can see, the cache now stores only one IP and one MAC. We would like the victim to notice us so that you can see how such an attack unfolds. Under the Sniffer tab, you can see the information about who's currently connected to the network. A couple of computers were found. We can see their names. We can learn that the victim's computer runs on Windows XP and that the IP ends in 115. Let's check again the contents of the ARP cache of the victim. Besides the address ending in 1, which is probably the default gateway, we see another IP ending in 125 and a MAC address ending in 42. It all pertains to the computer we will use to conduct the attack. For now, this is all we should remember. Back in the Kane-Enable program, we choose the ARP tab and we add the computer whose ARP cache we want to poison. We'd like to do it in such a way that enables us to intercept packets sent to the default gateway, which we will then forward to the router. And vice versa. If the router tries to communicate with the victim's computer, it'll send the packets to us and we'll forward them. We'll be the man in the middle. We start the program and return to the victim. Let's read the ARP cache once more to see what happened. The MAC ending in 42 is now associated with both IP addresses. The victim's computer treats the attacker's computer as the default gateway. It will send all the data to it. Let's try to send some data. We'll connect to a certain server. We're required to type in a username and password. We'll use test as the username and pass as the password. This data is incorrect, so we didn't manage to establish a connection. We can try connecting to a local network host and to open a website. Everything works just fine. We browse the internet. We could probably connect with a favorite bank's login page. When we try to connect to a website through the secure HTTPS protocol, it turns out that the site certificate created some problems. Likely, the certificate was issued by a company you have not chosen to trust. After closer examination, the certificate seems valid. It cannot be, however, verified. We had a chance to see that things look normal from the perspective of the target computer. It can still establish connections with web pages, with the FTP server, and with the network share items. Let's see how things look from the attacker's perspective. As we can see, some packets were indeed routed. We also intercepted a lot of data. Kane-Enable has an additional function. You can export the data directly to the Passwords tab. We'll find there passwords grouped into categories. Above, you can see the NTLM passwords, which we'll talk about later. By right-clicking on the password, you can choose the option to send to Cracker. Having the LM passwords, we can find a Windows local network user's password in just a few minutes. This password would allow us to connect to the file server. The FTP server passwords are stored in plain text. If the HTTP passwords are sent as plain text, they'll be stored in that form as well. Let's stop the victim's ARP cache poisoning. We have to do that to prevent the victim's computer from discovering our real MAC address. The information we discussed before and the demonstration you've just watched should help you conduct your own ARP cache poisoning attack using the Cain-Enable program, which I strongly encourage you to do. You can try to use a newer web browser, for example the new Internet Explorer, to connect to an HTTPS secure website. It can be a bank's website or an email web page. The web browser here doesn't really matter because the attack is conducted on a very low layer of the OSI model, and the web browser trusts data sent from the lower layers. Whatever browser you use, you should get an untrusted certificate error message. In reality, we don't connect directly to the website, but rather to the man-in-the-middle computer. We connect to the attacker's computer who sends the data forward. The certificate is issued for a specific computer and won't be compatible with the man-in-the-middle computer. Doing the exercise, you should ignore the untrusted certificate error message. It'll allow you to connect to a website. In the HTTPS secure form, you can type a login and password. They will later be visible in the Cain-Enable program. There will be no need to decrypt them, and it's not an encryption issue. The password will be visible because the victim has sent it to the attacker voluntarily. The untrusted certificate error message was triggered by the certificate issued by the Cain-Enable program for this particular session. In this way, the program enables you to connect to the HTTPS secure website. It turns out that the victim encrypts the data with the attacker's encryption key. The attacker decrypted them easily. Next, the attacker encrypted them again with the website's encryption key and sent them forward.